All right, guys, here we go again. Transformations of exponential and log functions. So two kinds of functions. Transformations we've been doing all year long. Should be no problem. All right, it says describe the transformation of this 1/2 to the x power represented by this 1/2 to the x minus 4. Well, you know good and well that that minus 4 at the end means it's been shifted. It's supposed to be shifted down 4 units. So I'm going to go down 4, 1, 2, 3, 4. Draw my asymptote right there. Remember how we graph these exponentials? We put a point 1 above, and then we're going to go 1 to the right. Whatever that base is, we're going that high, we're going to 1/2 right there. And because it's less than 1, it's exponential decay. So the graph is going to do this right here. And that's all it's asking you to do. Okay, so the first part of tomorrow, piece of cake. Second one, just do the same thing. This time we're going to have e to the x. We're going e to the x plus 3 plus 2. Now, because that plus 3 is in the exponent, that's going to shift the graph left 3, opposite of what you think. And because there's a plus 2 on the outside, it's going to shift your graph up 2, exactly like you think. So I'm going to go left 3. First of all, the up 2. I'll do the up 2 first, because that's where the asymptote's going to go. All right, oops, that's not a very straight asymptote. Let's try that one more time. Asymptote's up 2. Now, usually I would go up 1 for my first point right there, but because it's been shifted left 3, I'm going to go left 3 to right there as my first point. And then because the base is e, I'm going to go up e from the asymptote, 1 to the right, and go up e. Remember, e is 2.718, so I'm going to go up about 2.7 from the asymptote. Connect those dots, and there's your graph. All right, more of the same. Describe the transformations and graph each function. First one has been shifted 5 to the right. This also has a horizontal shrink, remember, by the reciprocal, by 1/3. So let's go this, the horizontal. So the asymptote is still at the x-axis. No big deal there. Now I'm going to go right 5. So usually I go up 1. I'm going to go up 5, 1 over 5 to the right. But it's also been shrunk by 1/3. So usually I take my point up 1, but I'm going to go over to 5 to the right. Let's see, 1, 2, 3, 4, 5. But it's been shrunk by 1/3. So 1/3 of 5 is about 1.6, 1.7, right around there. So there's my, where does that sound? There's my first point. The second point is going to be 3 up. If I go over 1, up 3, about right there. Connect those dots, And there's that one. I'm going to change colors here for the second one. Another one, this time, that negative exponent is going to be reflected across the y, because the negative is in the exponent, and that negative outside reflects across the x. Gosh, it's going to be a lot of reflections here. And then finally, it's got a vertical shrink by 1/8. That's a lot of stuff. Okay, so we got here. So usually, if it was just 1/8 e to the x power, I would go. Let me change colors here. I would go like, instead of going up 1, I'll go up 1/8, which is barely. So because it's been reflected across the x, I'm going 1/8 down. Also because I would go over 1, up 2.7, but it's been reflected across the y, which is there, but it's also been reflected across the x, which is down here. So there's my 2 points. That was kind of crazy. Connect those. Let's go yellow this time. Connect those two. It looks something like that. I kind of missed that second red dot there. All right, now we're going to logs. Describe the transformation represented by f represented by g. Then graph each. So the same stuff now, except for logs. So here we go. Same old transformations we've been doing. This one's going to have, the first one's got reflects across the y because the negative is inside. And it's also got a horizontal stretch by 2. Okay, the reciprocal of what's inside there. So let's see what happens. Okay, as you know, when we graph logs, the y-axis is the asymptote. And usually I'll start my first point right here, 1 in front, but it's been stretched by 2, so that point's going to go to there. So I'm looking at that second one, not the first one. And because it's base 10, I would go over 10, up 1. So over 10, up 1. However, it's also been stretched by 2, so I'd be going over 20 and up 1, which is what my graph. So I'm going to go up 5, up 10, up a half would be what would be right there. So the graph then would do something like this. It's kind of a very skinny graph, but kind of like this, like that. But remember, it's been reflected across the y-axis. So that first point will be here, second point will be there. Now connect, and the answer is the green graph right there, which is kind of crazy. All right, let's do the second one. Let me erase this real quick. All right, second one. Let's write the stuff down here. First of all, it's got a vertical stretch by 2, and it's going to shift left 4. Now, probably need to describe. I'm not doing a great job of describing what these things do. So let's go ahead and draw the asymptote here. Okay, usually I would start right 1. Oh, but it's been, I lost that. It's been shifted left 4. It's going to shift the asymptote left 4. So there's our real asymptote right there, left 4. Okay, vertical stretch by 2. Usually, as you know, we would put the point right here as 0, 1. Now, I start at 1, 0. Now, when you do a vertical stretch, you're really multiplying the y coordinate by 2. All right, so if you multiply, that point right there is really -3, 0. And because the y coordinate is 0, 0 times 2 is still 0. So no big deal there. The base on this thing is 1/2. So if I go over 1/2, I would go up 1, which is right there, and should be good to go. But it's been vertical stretched by 2, so which means I'd multiply that y coordinate by 2. Since that y coordinate is 1, multiplied by 2, it goes there, which would erase that first point right there. So again, a vertical stretch, you multiply the y coordinate by 2. In my first graph, I should have explained this better. If it's a horizontal stretch, you multiply the x coordinates by 2. And that's all you do. Okay, so let's connect them. It's going to do something like that. And there you have it. Okay, got one more slide. All right, let's do this last one. Let the graph of G be a translation 2 units up, followed by a vertical stretch by a factor of 2. So I'm going to say f of x. Now we got to do the translation 2 units up first. So I'm going to do 2 units up. Would be just putting a +2 out there. Then it says followed by a vertical stretch by a factor of 2. So that means I'm going to multiply the whole thing by 2. That's what a vertical stretch does. So I'm going to multiply the log by 2 and also the 2 by 2. And there we have it. All right, so there's quite a bit of stuff in that lesson. We'll work on it, as always, a lot tomorrow. So come ready. That's kind of some good stuff. Remember, one thing to close on here. If it's a horizontal stretch or shrink, you're going to multiply the x coordinate. If it's a vertical stretch or shrink, you're going to multiply the y coordinate. Okay, it's that simple. And we'll work on that tomorrow. See you then.